So we learned about devices, their functions. Now we are going to focus on addresses. You see, every device, as I said in the previous class, I have a name, but that is not unique. The fingerprint is very unique. That's how God has created. That's the real name of a person. That's the real name of a person. That's how person can be identified uniquely. A thumb print, a fingerprint. But name is what we we use in order to call someone or point out someone. We don't use fingerprint. We use name to call someone. We can't, but we do verify the authenticity of a person using the fingerprint. Like when you go through immigration, they may ask us our name. Okay, what's your name? I'm Jayachandran. Okay, can you keep your finger, the thumb finger, on the scanner? Then when I keep my finger, they check the authenticity. They don't believe what I say 100% by seeing the photo on the passport, comparing to my nose, my mouth, and my face. They still don't believe 100%. They want to verify one last time with a fingerprint. That's the real confirmation for them to accept us into their country. The thumbprints, the fingerprints. Likewise, every networking device have got a MAC address like a thumbprint. And IP address as a name of a person. You see, you should not have same name for people in a family. That will be big confusion. In a family, we need to try to keep names unique so that when we call, there won't be a confusion. Likewise, in a network, within a network, within an organization, we should not have two devices with same IP address. So MAC address are already unique that we don't need to care about. But IP address we need to really take care because conflicts will come if you put same IP address to more than one device. I cannot give more than one device same IP address. For example, if I give 10.0.0.1, 10.0.0.2, 10.0.0.3, and I've forgotten that I have given 10.0.0.2 already. And if I say 10.0.0.2 again, then there is going to be a conflict. Even though IP addresses are logical address, means they are not permanent. They're not permanent for any device. They are not physical address. MAC addresses are physical address. They are hard-coded into the device. Whereas IP address is a logical address, meaning you can have 10.0.0.1 here today, tomorrow you may change it to 20.0.0.1, no problem. So today I can be called as Jayachandran. Tomorrow, if I don't like that name, I can change my name and update it on all the records. I can have a new name. But I cannot have another fingerprint. In this life, this is the only fingerprint I can have. I cannot change it. So they are physical address. MAC addresses are physical address, cannot be changed. Hardware address, it's also called as hardware address. It comes along with a manufacturing manufacture device. It comes with that, cannot be changed. But the IP address, when I use my computer, my router gives this 10001. If I sell this computer to someone, that someone connects to his network, maybe his network will give different address, not guaranteed the same address. So the address, IP address, are not always same for a device. Sometimes you will get the same IP address from your router, sometimes not. So if you allow the router to assign IP address to your laptop, to your computer, routers will use a service. Let me draw a router here. Just we put a round to say router, and we put a square box to say switch. So I have a router here, and in this router we will be enabling a service called DHCP, Dynamic Host Configuration Protocol. Dynamic means you know what it is. Host means this is a host. It needs an IP. So dynamically, an IP is configured by a protocol called DHCP, Dynamic Host Protocol. So when you enable a DHCP service, what does that mean, enabling DHCP service? You'll create a pool of addresses, like starting from 10.0.0.1 to 10.0.0.50. So in this pool, there is 50 address. So whenever a new device is connected, from the pool an address will be given, 10.0.0.4. When DHCP gives IP address, there will not be duplicate. And this will be fine. DHCP will not make that mistake of giving same address to more than one device. Not possible. But when we configure IP addresses to the computers manually, there are chances that I may type the same number and these two will be conflicting. So when you're configuring manually an IP address to the computer, statically an IP address to the computer, make sure we don't do duplication. With DHCP, we don't need to worry about it. DHCP will never assign same address to two devices. Not possible. Why? Because DHCP, what it will do is it will take the MAC address of the device and give an IP address. For each MAC address, it's going to give an IP address. For each MAC address, it's going to give an IP address. When the MAC addresses are different, they are going to get different IP address. So no chance of getting same IP address for two devices if DHCP is in use. So what we are learning here is we have two type of addresses. One address is permanent, we no need to assign, you no need to worry about. But the other address, you need to really take a good care. We can assign an IP address using DHCP, which is less burden for us. But if you are planning to assign statically the IP addresses statically, then we need to make sure we don't duplicate, we don't assign same address to more than one device. That will create conflict between the device. As a result, there won't be any communication. Now, what is the size of MAC address? Do you remember the size of MAC address, which we learned long back?
Sorry, 48 bits.
Exactly, 48 binary bits. And the size of IPv4 address is?
32.
Now, you remember these things or you are referring the notebook?
I remember these.
Wow, nice, I appreciate. Now, do you remember the size of IPv6 address?
I'll have to look for that one because that was the large one.
Okay, 128, okay?
128, yeah.
128 binary bit. So we got addresses to identify device. Now, this addresses for effective usage, meaning using it without wasting. They are classified into 5 groups. Class A is the address which is going to provide you a large number of addresses. Class A addresses. When you have a class A network, you can have many IP address. For example, if you get 11.0.0.0, how many IP addresses you can have? For that, you need to know how many bits are here. There are 24 bits. So 2 to the power of 24 minus 2. Why I put minus 2? One is this one 000 we cannot use. Another one is 11.255.255.255 which cannot be used. This is a broadcast address, this is the network. So minus 2. In between what you have 11.001. Starting from 11.001, it goes till 11.255.255.254. Now, how many addresses are in between these two? You need a calculator for this. Can you calculate and tell me how many IP addresses you will get when 11 network is given to you? How many IP addresses you will get? Calculate and tell me.
You said 11 networks?
Yeah. How many IP addresses you can get? Maximum of how many IP addresses you can get? Use the calculator. 2 to the power of 24 minus 2 is the answer. That many number. You got it? Well, let me try to help you. Calculator. You see, you need a scientific calculator to do this. If you don't have, you need to click on this and click on scientific here. 2 to the power of 24 is this big number minus 2. These many IP address you will get 1677214 1677214. Just this one network 11 can give you these many IP addresses. 11001 is one IP address, likewise 11002, 11003, 11004. Keep going like
And where
that.
does the of 24 comes from? Like, where does that come from?
Okay, what is the size of IP address?
The IP is 32.
32. And look here. This is how many bit? We saw in the previous class, 32 bit is divided into 8 bit, 8 bit, 8 bit, 8 bit, isn't it? Now, this is already network. This 8 bit is already taken for network. Now, how many bits are left?
3.
24, right?
Okay.
8 plus 8 plus 8. 8 multiplied by 3 is 24. So you got 24 bits for the host, for the devices. For network, 8 bit is already given. In that 8 bit only you made 11. You know how to write 11, right? How to write 11 with 8 bit. 0 0 0 0. Hope you remember
I
these
remember
things.
those.
We
I
did
don't
this in the
remember
previous
8.
class.
Right. 8.
1. No. I'm not asking writing 8. I'm asking you to write 11 with 8 bit.
Okay.
8 plus 4 is 12. Then this would be 0 1 1. This is 11. This 8 bit. This is 11. Do you agree?
11.
Check.
Check right now.
How
Okay.
this is
Yeah,
11?
that is 11.
11? How is it 11?
Because we have the 8, the 2, the 1.
8 plus 2 plus 1 is 11. So what does this mean? You know, this means that this is masked. This 8 bit is reserved for network and it is 11. And other 24 bit is there for you to use as the ID for the devices. So to identify a network, you have only 8 bit. To identify devices, you got the remaining bits. In 32 bit, only 8 is for network. The remaining 24 bit is for the host. That's why I say 2 to the power of 24. You got it? How I got 24? You understood how I got 24?
I see now. I'll probably have to look back over it though a few times.
No, I can repeat it. Let me repeat. You see, the size of IP address is 32 bit. In that 32 bit, if it is class A, the first octet, the first 8 bit is network. The other 3 octets are for the host, for the computer to be identified. So if you have 3 octets, you get 24 bit for the host. So to calculate the number of hosts per network in class A, you use this 2 to the power of 24 minus 2, and you get this.
Okay, that made more sense. Let me see if I have a calculator on my.
Okay.
If I can pull up my calculator also.
Yeah.
Okay, I have it on here. All right.
All right. So class A means you don't have too many network bits. Only 8-bit is for the network, and 24-bit is for the host. You
Yep.
got it? That is class A.
Okay.
Now, this class A, how do I know whether an IP address is class A or B or C? For that, if you find any IP address beginning with a number between 1 to 126, then that address is a class A address. If you see an address beginning with any number between 1 to 126, it's a class A address. So in this address, the first octet is for network and the other octets are host. For example, 10.12.128.192. Is this a class A address?
Yeah, because it starts with it.
Yes. You should see only the first octet. Don't see the third. If you see the third octet, it looks like, not in this range. But it is a class A. Don't see other octets. You need to see only the first octet. If the first octet is a number between 1 to 126, then it is class A. Now, in this address, class A address, this is the network. What network this address belong to? 10 network. And what is the host identification? 12.128.192. That is the ID for that computer in that network 10. In that network 10, it is 12.128.192. That's the ID for that computer. Instead of using the word computer, I can use host. When I say host, it is a very common noun. Like when I say host, it means computer, it means any device that will use an IP address. Not only computers use IP address. iPad use IP address. Printers use IP address. There are various devices. IP address is in use. Servers use IP address. If you're connecting your motorbike or a car to internet, they need an IP address to be identified. So they're all host. So whenever I use the word host, you need to understand, I mean a device that is the part of network. A device that is a part of network is what we call it as host. That host can be a router because the router also needs an IP address. Okay, now let us go to the next class. I told you there are 5 classes. Class A is over. Class B is any address ranging between 128 to 191. If you find any address beginning with a number between these two, between this range, then you call it as class B. In class B, first 2 octets are network. First 2 octets are network. Then how many bits are for network?
It's 8.
How many bits are for?
You said for
No,
network.
no. I told you there are 2 octets are network. Then how many bits are for network? For network, if there is 2 octet given, tell me how many bits
16.
are for. Exactly. You're right. 16-bit. It is 16-bit. Yeah. So 16-bit network and other 16-bit is host. 16-bit is network, 16-bit is host. Now, example 172.16.100.200. In this, can you tell me which portion is network and which portion is host?
So 172.16 is the network.
Exactly. 100.200 is the host. Host identification. Now, class C, ranging between 192 to 223. If you see any address starting between this number, then it is class C.
Okay. So for class A, I see 1 through 126. Where would 127 be?
We'll talk about that. Give me some time. All right. That is reserved for something else. So let us finish this class and then we'll go to that topic. That's next topic. Now, it's a good question. Where is that 127? I'm seeing 191 here, and it continues here 192. Why it is not continuing here? 126. Why 128? What is that 127 is? Or why we are not using it? Good question. We'll talk about that in a few minutes. So class C, any address ranging between 192 to 223. It's class C. In class C, can you guess how many octets are network?
24.
See, yeah. In class A, 8-bit, 1 octet. In class B, 16-bit, 2 octet. In class C, 24-bit. This is also network. It's also network. So 24-bit. So for those who need less number of IP address, class C address will be given. Can you tell me in one class C address how many IP addresses we can get? For example, I have 192.168.1. This is the network. In this network, how many IP address I can have? This 8-bit is for the host. This is the network. First 3 numbers are network. How many hosts in this network I can have?
Host? Oh, 8. I'm sorry.
Yeah. How many host addresses?
Oh.
No. I'm not asking how many host bit. I'm asking how many addresses.
Let's see. Is that the 223? Okay.
Exactly. Well then, I appreciate. 2 to the power of 8 minus 2. 223 addresses. You are right. So we got class A, B, and C. Class C, it's only 8-bit. So you can get only 223. So if you are running a company, an enterprises with less than 200 people, 200 computers, you don't need a class A or B. You just need a class C. Because you don't need too many addresses. If you buy class A address, it's of no use. Or if you're planning to use class A address, it's of no use. Not necessary. It's too big. All right. So you understand why they are classified like this? Depending on the size of the requirement, you can have an address from one of this class. Now, we have finished 3. There are 2 more classes. Class D is the address ranging between 224 to 239. But this range of address are not used as IP address of a host. You understand? This is a range of address which is dedicated for another purpose called multicast. Multicasting. So you cannot assign this address as an address to identify a computer. You cannot use any address between 224 to 239 in order to identify a particular device. Then what for this address? These range of addresses are meant only for identifying group. To identify a group so that you can send the traffic to all of them. That is what called as multicast. It is not unicast. It is what? Multicast. What is unicast? Unicast is sending to any one of the class A or B or C address. On particular device, if you are sending traffic, you need an address. That is called unicast address. If you're going to send to a group of device,
multicast,
then you need what? An address to identify the group. That group address is what called as multicast address. Multicast address is to identify a group. Unicast is to identify a single particular device, a single device. Multicast is to identify a group. For example, if you have 100 computers, you may have 10 computers in one department. To identify the 10 computer among the 100, you will assign the 10 computer with one common IP address so that when you send any packet to that one common IP address, all the 10 can receive. For example, in a school, say for example, you are in a 4th standard. Sorry, let's say there are many standards in school. So if they say this is a message for all those who are in 10th class, what does it mean? It doesn't mean a student of a 10th class. It means every student in 10th class. If there is a person, Imran, then it's a unicast. It's a person it's a name of a particular guy. But when you say 10th class, including Imran, there are many other people. It's for everyone. That's what multicast is. 10th standard. If you're addressing to the name 10th standard, 10th class, then it means multicast. If you're addressing to a person called Abraham, then it is unicast. For unicast, you cannot use class D. For unicast, you need to use A or B or C. For unicast, you need to use A or B or C. For multicast, you will use class D. Now, there is also another class which is not defined yet. No range, nothing. They call it as It's a research and
research and
development
development
class. I mean, still they have not defined. Yeah, still they have not come to a conclusion how to use that other numbers like 240 to 255. It's not defined yet. Class E is not defined yet. But we don't need to worry about E because we already have IPv6 version. So they are not going to define class E. They'll never do it because it's gone. IPv4 is going away slowly. IPv6 is coming. All right.
yeah.
Now, did you understand the 5 classes?
Yeah.
Now let me answer you this question that you asked. What happened to 127? You know, the 127 beginning address, any address starting with 127, it can be 127.1.1.1 or 127.8.9.10 or 127, anything that starts with 127. Anything that's starting with 127 cannot be assigned as an IP address to a computer. Why? Any address that's starting with 127 is
Look back.
considered as a loop
loop
back address. Loop back address. Looping back. Loop back address. What is loop back address? The address that you will use to diagnose. The address that you will use to check whether your computer is ready to be a part of network. For example, you see, I go to my computer command prompt. How do you go to command prompt? Type CMD. This is command prompt. I repeat, how do you go to command prompt? Go here, down here, and type CMD and hit enter. This is command prompt. Now, when I ping any number starting with 120, you tell me 127 dot, you tell me any number.
That's 6. You said any?
What?
Mm-hmm.
Dot 6.
2.
Okay. Dot again.
18.
Another number. 2. Another number. 18. You see, I'll get a reply. Who is replying me? Is there any computer with this IP address? No. Then who replies to me? It's my own operating system. What does it says, by replying this, it is conveying a message to you. What? I'm ready to be a part of the network. When you don't get this reply, your computer has got some problem. Maybe there is a driver issue, maybe the damaged port, something like that. If you are able to ping any number after 127, you can put any 3 numbers, and if you get reply, it means your computer is good to be a part of internet. So this is a self-diagnostic testing address. You can try now. Go to your command prompt, try pinging.
It says not recognized as an internal external command.
You type the ping command,
Okay,
PING. Check the spelling, please.
Still giving me the same thing. Do I just type in ping or do I type anything? What did you? Let me look at yours. Let me see. Oh, I didn't type ping and then the IP address. I got a reply now.
Okay. So after 127, you may use any address, any number. You will get a reply, which means your computer is good. Your computer can be a part of internet. So you are able to test yourself. You don't need to ask for a technician to check whether your computer is eligible to be a part of network. You can do it by yourself. That is why we need this address, loopback address. So don't try to assign this IP address to any device. It won't accept because it is not for identifying a device. Rather, it is to do a self-diagnostic test. You agree? Self-diagnostic test. Okay. So what you have learned is the classes A, B, C, and D. D is in research and development, so no need to worry. Sorry, E is in research and development. D is multicast range address. What is the range for multicast? 224 to 239. And what is the class B range? 128. It's not 127. It is 128 to 190. You need to remember this range.
Yeah.
Okay. Are you ready? I'm going to ask you a few questions. Are you ready? Okay. Now, I got 200.0.0.1. What class address is this?
The network portion is 24.
What is the network portion and what is the host portion?
Oh, am I looking at yours?
You shouldn't. Okay, then I appreciate you're right.
I'm sorry.
But 200.0.0.0, that is what you should say. The network portion is 200.0.0.0 and the host portion is 1. Okay. Host identity. Now, 178.0.5.10.
That's class
what class
B.
It is? And what is the network portion? And what is the host portion?
178.0. And then your host is 5.10.
Exactly. Okay, so the portion that you consider as a network, you need to put 255, which means these two octets are network. And the octets that you consider as a host, those need to have 0. So for class B, this is a class B address, right? For class B, the default subnet, it's called subnet mask. Subnet mask. Mask is, the default subnet mask for class B is 255.255.0.0. So tell me, what will be the default subnet mask for class C?
We'll have 255.255.255.0.
Exactly.
2.5.
And for class A, let's say 10.100.200.150. What is the network portion in this address? 10, isn't it? And the other remaining portions like 100 or 200 or 150 is the host. So how do you write the subnet mask? 255.0.0.0. So class A default subnet mask is 255.0.0.0. Class B default subnet mask is 255.255.0.0.
All right.
Class C's default subnet mask is 255.255.250. So don't forget these
And D
things.
doesn't have a subnet mask, right?
Yep.
Because.
All right. Now, what is next?
Okay.
No, there is no subnet mask
Right.
for class D and E because D is a multicast address. There is no network portion.
Mm-hmm.
There is no network or host portion. All right. It is to identify a group. Okay. So for the devices that are in the network, for the devices, if they do in the network, if they want to communicate, they need to follow certain standard. If they don't follow that standard, then others can understand. Others cannot understand. Um, for example, I was going in a train in I think it was from a place called Herlen in Netherlands. From Herlen to Netherlands, I think the airport name Atlanta or something like that. I was going, and on those days, I did not know that WC means a place where I can ease. I did not know. That's the European standard. I don't know. In India, they don't write like this. In India, it is different. So I was really looking for it, searching every corner because it was too chill early in the morning. I was going for a long distance, and the WC was everywhere in every compartment, which I did not realize that is for me to ease myself. But it's because European standard is different from Asian standard, from African standard, from Western standard. There are various local standard as well. So now, what am I trying to say? ISO has prescribed a standard for Open System Interconnect. This is the standard that ISO has given for any network participating device to refer. So this is the reference model that someone should refer if they are designing a networking device. If you don't have a common standard, see the problem. If you have European standard, Indian, there's a common standard. As a result, I was in confusion. So there should be a common standard. You see, I'm in India, Bangalore, and you are in somewhere in US. When I speak through my computer, my mic, my screen, when I share, you are able to see there. It is because universally there is a standard followed by your computer and my computer, by all the computers on the earth, called OSI. Otherwise, you cannot understand. When I speak, your computer will not interpret exactly the same way that I say if standard is not followed. Because standard is followed, the bits that my laptop generates because of my voice and my screen share video, it is matching with your standard. That is why exactly what I am writing, you are seeing there. I have written here ISO, I have put 2 lines, and I have an arrow mark here, I have written a reference. You are able to see exactly the same thing that I'm writing here because my laptop, whatever it generated, your laptop can understand and interpret exactly the same meaning. How is that possible? Because there is a standard followed by your
I have an
manufacturer
HP.
and my manufacturer. What is your make, your computer make?
Mhm.
What is the, okay, you see, you have HP. I really don't have HP. You see, mine is totally different. Mine is Dell. Let me show you. Mine is not HP. So, though it is different vendor, we are able to see exactly what I am sharing. It is all because of a standard. Dell has followed standard, and it's the same standard HP has also followed. Where can I see? Mine is Dell. And my operating system is Windows 10 Pro. I don't know yours. So they're different. My processor is different. Your processor is different. Though we are able to communicate because the operating system, whatever the version may be, has followed a standard. My computer standard and your computer standard, they're all same. Yeah. So there is a standard needed. English is a standard to talk to anyone on earth. Anyone can understand. I really do not know your mother tongue. I don't know what you speak in your home, but I'm able to communicate to you. I did not have a second thought when you enroll because I know very well that you can understand English because we have a standard language. So when I speak, you understand. When you speak, I understand. We got a standard to follow. Likewise, my Dell computer language is well understood by HP computer. And there may be some students with Mac, with some other Sony, Toshiba. They all can understand what I speak. It is all because all the computer, regardless of vendor, they have followed one reference model called OSI. Because they all followed this model and developed their computers and sold it to us, our devices can talk to each other and understand the meaning without any mistake.
Yeah,
Did you understand why do we need this OSI?
I couldn't hear you.
All right. Now, who proposed this
You said
OSI?
the OSI?
Who proposed this OSI? Yeah. Who proposed it? Who gave us the standard? ISO. ISO has given this standard. ISO is Industry
System
Organization
Interconnect.
for Standardization. OSI is what? Open System Interconnect. Totally different. Maybe the characters are same, but shuffled, but they are not the same. OSI is Open System Interconnect. This ISO is Industry Organization for Standardization. You should not write iOS, but we abbreviate it with iOS. It means Industry Organization for Standardization. That is how we need to say. But when you write, you need to write ISO. So it is the ISO's proposal. ISO has developed the standard for us for the networking called OSI. Now this OSI has got 7 steps in preparing the packet. 7 steps in preparing the packet. So if you are developing a laptop, that laptop should do the 7 step, follow the 7 step so that any device on earth can understand what you speak. what your laptop speaks. That 7 level of preparation is as follows. Level 7, application layer. Layer 6, presentation layer. Layer 5, session layer. Layer 4, transport. Layer 3, network. Layer 2, data link. Layer 1, physical. Okay, this is very important, and this order is also very important. You should not shuffle this. Even though application layer is on the top, we cannot call it as layer 1. Whatever a standard has given, we have to strictly follow it. The standard says layer 1 is physical, layer 7 is application. We need to follow this strictly. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer, 7 layers of OSI. You need to memorize this in order. So when I ask what is layer 3, you cannot say session.
Yes.
It is network. Are you okay with this? Now, understanding each layer will give us an idea how the data is prepared before sending over the network, so that any receiver can understand what I am sending. The receiver may be HP, the receiver may be Toshiba, the receiver may be Sony. I'm sending from my Dell laptop. Any receiving device can understand it because all the device on earth has followed this 7-layer approach in sending and receiving data over the network. When you have a common standard, you will easily identify what it is. So if they put a sticker like this, then I understand, okay, it's for, or if I see a sticker like this, I don't know, maybe like this. If I see a sticker like this, then it is male. I think so. If I have a sticker like this, and it's for female, maybe. I'm not sure. So instead of putting WC, European standard. So if I have a common standard, it conveys the meaning. Right? If you see, if you go from one country to another country, the big problem that we face is the plug points. When I try to use my laptop, my pin never goes inside the wall outlet. In Africa, in Europe, even in Dubai, in Arabian countries, because the Indian standard pins are different size than the other Middle East and African and European standard. There is no universal pin. A big problem. There is no standard. But in networking, it is good that we have a standard. That is why, regardless of the continent, we are able to communicate, convey things. The computers can understand each other very well. When I write an email, it is exactly the same information that I conveyed, you are able to read. It is because there is a standard. So as the word says application, there is going to be an application in your laptop Right now, what is the application that I'm using? This is the application, Google Hangout. This is the application that is generating my voice to you. And when I write, it is that application that is presenting my screen to you. That's an application layer which can interact over the internet to you. That's why it is called application layer. I'm using that layer and I'm presenting what I want to present. It is taken in a voice format and the video format and given to the network. And a time is given for my packet to be delivered. If it is not delivered on time, then my laptop may say error in sending data or something like connection problem, something like that. So there is a session maintained for every data that goes out from my laptop. And it is transported over the medium according to the capacity of the medium. See, some may have a very less bandwidth, some may have a big bandwidth. According to the bandwidth, according to the link, some may be having Wi-Fi connection, some may be having wired connection. According to the type of media, the transportation happens. And also a protocol like TCP and UDP, we'll talk about this in another class, so it's an important subject, is selected for transportation. TCP can be used, UDP can also be used for transportation. Anyone can be used, but some application only needs TCP. Some application traffic only needs UDP. So we'll talk about that, which one needs what later. So it is the responsibility of a transport layer to pick one of this protocol for communication, for transportation of our data. And the network layer is the place where the packet gets an information to which IP address and network the packet need to be delivered. We just learned IP address. IP address got two portions, network portion and the host portion. So those informations are added to the packet by the network layer, so that the network will know to whom the packet need to be delivered. See, right now I'm talking to you. It is not delivered to Donald Trump. It is delivered to you. It is not delivered to someone in Australia. It is delivered to you, your computer. How is that possible? Because the network layer has put a marking saying the packet belongs to so-and-so network and so-and-so host. And the data link layer is the place where the MAC addresses is added to the packet. And physical layer is the one which decides how the packet need to be sent out. Should I send it through wirelessly or should I send it to a wired media? It depends on what you have. If my laptop is having wire connection, then physical layer will decide not to send via Wi-Fi. It will use the wired one. If I don't have wire, if I enable wireless Wi-Fi, then my laptop will decide to use the wireless instead of wire. That's the responsibility of the physical layer. Physical layer will decide how we are going to communicate to the outside world and how we take the traffic from the outside world inside the device. All right, so more about this is going to come in our next class. We'll have this in the next class, OSI layer one more time with more in depth, and then we'll go to next portion. So too much